Hello everybody and welcome to our webinar about layout and calculation of EV chargers based on Caneco software. I will wait some more minutes for all the attendees which are coming now, because as you know a lot of attendees just coming up in just now. So let's give them some more additional 1 or 2 minutes and then we will start immediately. Oh, still several attendees are coming in. I think one more minute more and I will start. Okay. We have 11:02. I think we can start. For all of the rest which will coming later, it should be not a big deal. First, I will introduce myself. Just for this, I will also switch on my camera that you see me once and know who is the voice which is speaking now to you on that point. First of all, thanks all to visit our webinar here. Webinar is just a bit based on the EV chargers, because now it's a actual situation. A lot of EV chargers are installed. I'm not sure if really everybody is calculating the correct fuses, the correct cable, and so on. So I will show you a workflow in which way it could be done by Caneco 1. In that case, we will go through a plan which is made by AutoCAD. In our place, it's an add-on by implantation, where we will place all the components, EV charger, also some luminaries maybe, and connect everything and make a full calculation about the cable and the dimensions of the cable, and also about the fuses which will be needed to connect everything to the distribution boards. So I'm not sure how familiar you are already with ALPI or with our software. So I will just keep some notes about us so that you know who we are, where we're coming from, and what we're doing. So I will also switch off my camera so that you can concentrate fully on the screen instead of my camera. Just for me, I'm Mike Miller, business developer for the international market at ALPI. If you have any request and you are coming, not important where you're coming from just now. So just if you have some requests to the software, some questions, you need an inquiry or something more, just contact me. I will help you. I will support you. Otherwise, I will give you also the correct contact which have to support you personally. Just for us, ALPI, the guys who already know our software, European leader in automated calculation software for LV electrical installations. Quite important, we are coming from the calculation. So we start our software at Caneco BT mainly before. The last years for sure coming up with also implantation and Revit themas. So we will go through the software on implantation, but the same what we do now will be also possible with Revit if you need it. You see, we are not start up, we are not a newcomer, we have already 35 years of experience and also just more than 130 employees worldwide. For our suite, we provide Caneco 1. Caneco 1 is a software suite which integrates Caneco HT, TCC, BT, BIM, and implant. We start in the last part, Caneco implantation, because here we will also concentrate on our software presentation today. Caneco implantation is an add-on for AutoCAD. Also in our package of Caneco 1 is one Autodesk AutoCAD OEM license integrated. Caneco BIM is an add-on for Revit. We are not delivering Revit to you, so you have also to know Revit and to use Revit in your company for go on with electrical engineering based on Revit. The same we can do with implantation, we'll do also completely with BIM. Most common part is Caneco BT, is the calculation part. So everything you before you've done electrical design based on implantation or based on BIM, you can make a full calculation, including just import your project from BIM or for implant to BT, calculate it and give it back. Otherwise, you're also able to prepare it just on Caneco BT side. Maybe one more notice. If you have any questions, just put it into the chat. Just after the webinar, I will go through all the questions and will give you an answer as fast as possible. Maybe I'm also able to show something more based on the webinar, depending on our time schedule we have just now. Okay. So let's go. It's enough of the software mainly. So let's go directly to the software. You see here some prepared drawing. It's in the end just a drawing for a parking system where the customer wants to place EV chargers based on the parking. On the left side, you see a 2D drawing. On the right side, just a sketch of the 3D drawing that you see that we are working directly in 3D. So we can also export a 3D DVG for each time of BIM national needs if you want to export it or to compare it with different other tools. I prepared some luminaries here because it's not a big focus today on the luminaries, but I only placed some luminaries. Also, I already placed just a cable tray because if we will connect some components, we want to connect them to each position. So, but we will start with the EV charger. You see here parking places for EV cars, electrical vehicles, but there are still no charger at the drawing. Here we'll go through. To be honest, there are different ways to connect and to place components by Caneco implantation. I will show you just one way, which could be the fastest one in this position. So we will define a switchboard. Mainly, if you're not so much familiar with Caneco, here you see general AutoCAD functions because it's AutoCAD where. And we add with Caneco implantation all the needs we need for make a full electrical design because AutoCAD, I can say it's stupid, but it's a 2D or 3D drawing, nothing else. It's a drawing. We have usually no cable rings, we have no automatic cable routing or something like that. All the needs, all what we need for our calculation, for our electrical design, we add with Caneco implantation to AutoCAD. Similar situation also with Revit. So if you have bigger questions on Revit and you want to see how it's going on with Revit, we can also do a one-to-one session and make the same situation with Revit. So we go further here. We will place first a switchboard. Define the name of the switchboard. It will be maybe here UV001. Depends on you how you want to call it. You can define also different type of symbols here. We place it here in our technique room, just here. Now we want to add directly, it should be 23 charger, if I'm right. 1, 2, 3, 2, 3, 4, yeah. 24 charger. So I will go just here, add a manual circuit because I want to define it directly as a charger and use the EVC 3-pole charger. I can also add my personal reference mark. It could be something like that. It's on you to find. You can add type of the cable, type of the usage, the height of the installation, and also for the cable, and so on and so on. So you can define anything you want. Just now we will add 24 EV charger directly. So you don't see anything. Why don't you see anything? Because we have now the EV charger at the Caneco Export Explorer. Here you see all the circuits I prepared directly with the function just now. How can we connect now all the charger? First, we have to place also the symbols for the charger. Let's take something from the library. I just do it on the side and we go further. So we have something like here 4 kV electrical range. You can also use a DVG file from each supplier and give him this function. It's on you which one you want to use and to define here. Let's just start with the 4 kV electrical range. For sure, later we will change the situation a little bit and change also the name and also the power consumption based on Caneco BT, because we want to calculate here in the end with 11 kilowatts or maybe also to 22 kilowatts. It's to define. So you can also write in the chat which one you want to have maybe. So you have several options to place components by Caneco. We can just simply placing. So like here, we can just define, okay, I place a charger here by hand, step by step. 1, 2, 3, 4, 5, 6. Option number 1. So it's also okay. We can also use a different function. So in that case, we can take, okay, I want to have a linear network. So I can just define from here to here, I want to have 6 EV charger. Just define the offset and ready. That way we can place a lot of charger quite fast. We can just go further just to have it linear directly every time. Next one here should be 3. And again, next one. Where we don't have. Here we don't have. Also 3, offset, off, and so on. Here we have 4. There we have 2 more. And it should be ready. Just to check if we have all charger here, you see we have all parking for an electric vehicle has now a charger. Perfect. How we connect them now in the correct way? So in the end, we can also just cover all of them. Say cover all and connect it with one circuit or with all different circuits. But in that way, we will not define correctly it's number 1, number 2, number 3, number 4, and so on. But we want to define it in detail. So I will start with our Caneco Explorer here. Quite easy. I want to have this one, first one. You see, I will cover here and say connect. What happened? You see already cable routing. Also in 3D on all positions, you see already cable routing. So this one is now connected with the first fuse F101. Next one, connect up. You will see also they will also change. I think this one will change also the cable routing. Will go, yeah. So the cable trace. Next one. And also here and here. You see how fast you can connect all the EV charger to the board. You have a cable routing. For sure, the cable tray which I placed is just an idea. It's maybe not the best way because it should be also connected here for have all the cable routing correct. But it's on you to define the cable way. If it's a cable tray or a different type of cable way, free for you to define it. The cable routing use every time the shortest way between the device and the defined cable way. So you see every time different way because it chooses every time the shortest way between this device and the cable way. Also here we will connect all of them clearly with clear detailed information. And don't forget also this one. And also this. For the luminaries, it's on us in which way we want to connect also the luminaries. It's not so important for today, but it's just to have some difference between not to have just the EV charger, also have some additional electric components which should be also installed in such parking space. So I will just cover the components I want to connect. It should be this one, and say just we can close this window. We don't need it anymore. and say just connected with a new circuit to the board. You can define the style. We also this it's not necessarily directly, but we can define and also define different type of cables, different type of installations, and so on. So we can define all things we want to define clearly on the spot. So here also, okay, connected with one device. You see here also it's everything is F125. We have some more here. Maybe we will make also one circuit on this side, connected with one separate line. Wallet. Also here, one circuit. You see how fast it goes, so you can easily connect all the devices to this bushing board. Also ready, don't forget also this one, your circuit, and also this one. I think the luminous on the left side we can skip because it's in the end the same way to connect all of them. So you see, all of them use the shortest way between the last device and the way to go. So here at that point, just this cable tray. Now we have all connect. We have fuse for everything, so we can also maybe check the situation of the cable tray. Let's take this place because here we should have a lot of cable on the cable tray. We make a check section, and I want to see the situation here on this point. You see here, in the end, you see an empty cable tray. Why? Because all the cable we used just now are cable which have to be calculated before we can see them on the cable tray. Number of layers and so on. We can also devise here, but we can come back later because we have to calculate first. So let's place the section here for a later use. For send all this to the calculation, we have also, we don't need, but we will do it now. Also, we have to connect the UV001 also to a main MSB board. So we define one more board and say MSB. Can also define a drawing and place it just near each other. So now we have a UV001, we have the devices, we have a cable tray, and we have an MSB board. Let's connect also the sub-distribution board to the MSB board. Define, and we define also the board. However, 3 phase directly. Connect. Okay. So the electrical design mainly is ready. So we have all the information, we have the luminaries, we skipped this one, okay, but we have a lot of luminaries, and we have, quite important, the EV charger, which is an important part. So if we place it, we have also a cable length with all the information we need now. I will export it now to Caneco BT. I will export everything because I want to calculate everything we have here just now. Save it as a database. So now we will use Caneco BT for calculate everything which we have made before on the design. We will start on an empty project, completely empty. For start a project, an empty project, we have to define the catalogs we want to use. In my general settings, it is Schneider catalogs, but just so that you see it once, you can define the catalogs you want to use. It should be Schneider, Merlin, ABB, Legrand, Eaton, ABB. So everything what you need is in the catalog. Just choose one of them and ready. You can also make different catalogs based on the project. So in the end, you can have a mainly the catalogs which we place its default settings is just not to add every time a new catalog to the process. Because usually if you start a project design, you will not choose one times Schneider, one times ABB, one times Hager or something else. But you are able to change the type of the catalog, the type of the user process, type of the cable, user process on each position. So you can have MSB board with ABB components. You can have an sub-distribution board with Hager components and additional one with Schneider components. And you can make a full calculation completely over all manufacturers completely. So for here, we will start at one space. We have to define a supply, which we don't have on our project just now. It could be a transformer. It could be also a gun set or both. It could be on board by A key or RX, depend on what situation you are. It could be also DC current. In our case, it's not so much important because we will go through a different way. So define the standard. On my place, it's now it's German VDE. It could be also the ESC or a different standard, which is integrated in our system. So you see a lot of systems inside. We will define the third MCCP breaker in the direction to the MCP board, and we will calculate our supply. Caneco use every time the easiest or the lowest and the easiest switch which match the actual needs in the project. So every time the cheapest one from the catalog, mainly to say. So if you already want a bigger one, you can choose it and go further. Here will not change. You see we have a cable dimension and so on, but this is just for our supply. We will go through the project later. Here you see the workspace of connectivity. Usually, if you are not using Caneco just now, you will go to you will use a, I don't know, AutoCAD design tool, drawing tool, where you place all your components, connect them, and you use a calculation tool. Maybe Caneco BT, maybe something similar, maybe just Excel file or your calculator. It's on you what you're using just now, but for sure it should be a tool like Caneco BT. It makes you more efficient, and also you will have a full documentation of the project with all information you need for the government and so on. So here we can just also start by hand. New circuit, add a board, at the board, maybe at the socket, or add also a charger. So also here we are able to place directly a charger and go further. Option number one. But we have already a project, we have placed already the components, and we want to go on the project without to start it again. So maximum important point for Caneco is efficiency, to be as efficient as possible. So here we are. We open our project, which we prepared before, and export. And here you see already our MSB board, our circuit UV001, and all the connection we have done already on Caneco implementation with the cable links, with all information you need. I just say okay, and we import all of this to our project. Just here to see it's a charger, 4000 watt, 22 meter, used cable is XPL, and okay, it's in German, it's on a cable tray. So it's to define also the way of installation and so on. So it's a C breaker. The type of the fuse is defined by us. So usually you use a C breaker, but you can also change it by hand to a different one. So it's on you. Everything what you see now, you see also here our luminaries. I just change the fuel, and you see here our charger, and here you see our luminaries. So all the circuits we have prepared on the implementation part. Everything which is red has to be calculated. Everything is in green is calculated and okay. So let's go on with our MSB board, with our UV001, I'm sorry. So we have a cable length of 7 meter, cable family, and so on. We have no consumption just now. So we have just to decide in which way we go on, because if we have already a sub-distribution board which is placed in a technical room, and you want to connect now 24 EV charger, I think it should be clear for everybody that for sure the designer who has placed it before was not prepared for such power. We can go further, same situation. So let be 63 ampere distribution board. Let's calculate it. I also can define here an MCCB breaker, depend, and calculate. So this distribution board, 7 meter, will have a cable type, it's XLPE. It could be also different. Now it's just coming up from the international catalog. And he defined the cable of 16 square millimeter. And for sure, again, one from the list, so one protection from the list, it's an MCCB breaker, 63 ampere. Okay, let it work like this first. And now we can just calculate everything which is behind there. For option number 1, we have to maybe to adjust the power. So you see, as I told before, we have started with 4000 watt. Usually it's 24 charger are quite a lot, but we will define still with 11 kilowatt because it's a common charger. I think 22 or more, it's not really useful for such project. But maybe we can also do something different. We make some 11 and some with 3.6 kilowatt. But related as a 3+1 is just reduce the power which is going out. So in that case, so in the Excel file here on our Excel site here, you can define all changes by hand if you want. You can change the reference mark if you want. So we can just go further and say, okay, we want to change it. We prepared it as a drawing in one way. UV, I can now say UV01F, I don't know, just change it to a different one, 310. And as you know from Excel, you can just drop down and go through all the settings. Here you can change everything. Type of the fuse, protection type, cable length, cable type, and so on. So you can add all changes you want to change on the project. Let's go back and calculate our project. So now we will make calculation, full calculation, inclusive the power requirement, because I'm absolutely sure just now that 33 ampere, which we have as power consumption at the distribution mode, will be not enough. But let's check it. And as you see here, at the MSP board, we have available a reserve of 67%. Okay. On the UV01, we have a negative reserve in the end because we have 33 ampere, but we are in minus with 234 ampere. So it's a main situation which we have also in all the project just now, because it's not possible, or it's not possible to place a lot of EV charger in a project which is already ready, where we have just a general power supply and so on. So in that case, we have to check clearly if you are able to place such quantity of EV charger in a project, and which cable you have to use, and so on and so on. So now we will just do one thing. I want to have, I don't know, 25% of reserve on this UV001. So I will adjust it, and now Caneco will recalculate the completely project, also the UV001. We change also the cable for sure. We'll calculate now our cable for the charger and for the lighting, but we'll change also the cable from the UV001 and the fuse of the UV001 because the current is increased completely. Let's calculate and go Caneco to work. So now all of the compliance will be now changed, and you will got additional information on it. You see here already the fuse we done before. So this one, it's absolutely okay. Here on, we have, you are quite risky with our total down. So we can also change the type of the fuse, the type of the cable, or the type of power consumption. It's on us to define what we want to use, adjust here on that point. Also, maybe we'll just let it like that, because I will just give all the information now to the documentation, so we can go further what we have there. So also ready directly is our single line diagram. So you see here, also single line diagram is completely ready for such project directly. Now we go to the documentation. So now we can document our project. You see here also different type of languages, so you can prepare your project on, I don't know, German, English language, and export the documentation different one. You can prepare a folder for documentation, like legal documentation and so on. We will go, and this is all the letters you can export for documentation. Let's check now what we have here, like conformity sheet. So here you have all the information if a circuit is okay or not. What is here happening here? So in that case, you can see what is happening on all the circuits, in which way it's working on. We have also a single line diagram. or several signaling diagrams based on the components we want to use. Also here we have completely ready with all the information we have. Like here, you see the first one, not a big deal. We have 110 meter. The actual cabling is 96 meter. The maximum protected cabling will be 190 meter, and we have a drop down of voltage of 1.59 or 1.28. Just go to the next one. It's a bigger failure. So here we are quite near to our drop down voltage of 4%, which we have adjusted in our software. So I don't know where all of you are located. So, but this is just to define clearly on which position you are and what type of fuse you need to use based on the power consumption, based on your standards, and you can calculate it in the way you need it. Completely forward. So you see, also just go further to the last one, the luminaries, with all the information, with also the power used of L1, L3, or L2, and also here we have full documentation of the cable length, maximum protected cable length, and the factor which is decided that maximum 120 meter could be done is in this indirect contact. So we can also check the selectivity of our project. Distribution curve. You see, also here, completely ready documentation for the full project, just with some clicks. So, okay, we now go here. Here we changed our project, we changed the information, we changed calculation, and now we go back to our project. We can also make maybe one step more. Something I do with general demonstration also I will do just now. So if you see it once, you can also adjust the project completely here. We will add an additional board. I will just define it and let it be a 35 ampere distribution board. Calculate it, and what we do, we can reconnect these luminaries now from the UV001, and we connect them to the UV002. So also you can change your electrical design directly in Connectivity and transform this information or send this information to implantation. So let's calculate also this completely. And now we just save our project. Yes, do it here. And import it back to implantation. So I have all the calculation information back from there. So I can import the completely project. I will open it completely, and Caneco first will check the changes between the project we have here on implantation base and which is coming up from Connectivity. So first you see a lot of changes from my side. So I change the name and so on. And you see now, based on different colors, the changes which are done. Here we change the name modification. Here we change also the name of the circuit and also the connection, type of the connection. And we have also two new components. It's the supply and the UV002. Make it easy. I will cover everything and import it into our project. First, Caneco asked me, what do you want to do with the supply? Okay, let's place it here. Second, Caneco asked me, what do you want to do with the UV002? I don't know, but I think we could place it in a different place just to see that it will be reconnected everything. I will just place it here. And let Caneco work. You see, already start to reconnect all the cable. So now we have also here connection. If I cover now this connection, you see it goes not anymore to UV001, it goes directly to UV002. So just to sum up, all the changes you do on Caneco BT will be transferred back to Caneco and convert all information we need. So here we can also check what we have here. For the luminary, it's connected to the UV002. So the label is defined automatically by the information you want to define. UV002 connected to the now. This is an old reference mark, the UV001 F338. Also, if we change this information on Caneco BT, it will be changed also. And the type of the cable, 3 to 4 square millimeter. Let's check our cable tray. Just place it, and you see here now a lot of cable on this position of the cable tray. We can also go in and define it more in detail, maybe on a different space. Let's check what we have. Oh, let's check what we have here. Just again, and check the section here. Sure, we have less cable here, as you see here. And you can also define, okay, we want maybe to place it with different layers, 3 and so on. So it's on you to define how you want to place components. And what you see also, you see here a reference mark, it's a cable, like to be A1. You see it's a position 1, it's a cable number 11. It's a circuit UV001 319, coming up from the UV001. It starts, it's a complete lane and so on, type of the cable, I think it's clear. You see also where it starts, reference mark starts at the UV001, and where it stops. It's a component RCP52. It's just a component name of our EV charger. And also the name of things, it's an FICO-V, it's this information still in the documentation. It's a FICO-V charger. This we have to change manually to 11 if you change it on the Caneco BT side. So you see all the information you have. You see how big is the cable tray. You see maybe also the cable tray also not big enough. So on this position we see that our cable tray is not the biggest one. So we can also work with Caneco to reduce or increase the cable tray automatically based on the needs. So it's on you to define it. One more thing I want to show you. You can export now all the information you want to have as a bill of material. It could be just a list, which you can integrate based on equipment and so on. You see for all the components you make a list. You can make a list. It could be an XML or CSV file, which you can go further with component lists, Aveva, or something else. It's on you to define what you want for tendering, what you want to do. But we can also make just a legend. So we change to a legend. You see already here all information. We can define additional information. So like I want to have also the room description, maybe also the room name. It's inside. I don't place a room name, okay. And room type if you want, and all of these points you want to come to the fly, also where it's coming from, the supply, and so on. Total consumption of the circuit, what it is. So you can define each format, each information you want to see. It's area. Also, if we define an area on the project, we can define different type of areas like fire section 1, 2, 3, or parking garage, offices, and so on. All this information you will place, you can use as an export. So it's on you to define for all components, as you see. We can export it, as I told you, as an XML, or we place it just as a legend directly in the drawing. So it's on you to define it. The symbols the system takes directly from the library. One more thing we can define also, it's I just take this, it's synoptic. So also here you can define the type of the template you want to use for synoptics. We can use maybe an A4 landscape. You can define the boards where you want to place information, and you can define also the information you want to have on your components. So like now we have just the name. Let's delete it. We can define now, I want to have the circuit information. I want to have maybe, well, it's not important for the EV charger because it's every time the first one, but I can also define the reference marks for sure, but the number in the circuit, which is maybe important for fire detectors, for smoke detectors, because in that case it's important which position they are, or for emergency lighting. Also there you can define it, and we have full information about the circuit. Let's do it also here. defines the position of the reference mark and so on. So you can define anything and prepare it how you need it. And we can place it directly into the drawing. And you see, and your reference, when your completely synoptics for the project will be ready. You can define all the information you want to see. Maybe you just want too much here. So it's on you to define everything you want to have. You can define the power consumption to see, or the type of the logo and so on. All of this is possible to place directly into the drawing. So you see, it's in the end quite fast to make a design, make calculation with Caneco software. I don't know what you're using just now, but if you're interested on it, just come up to me. We can make a one-to-one session based on your project, and I can show you in which way it's possible to do it on your way. I see that we have some. Okay. You want to mix 11 and 22? I mixed 4 and 11. I think it's okay. So in the end, it's depends what you want. So you can also mix 3.6, 11 and 22, and maybe also 50 or more for make this calculation. So it's on you to define it. I don't know if we have some more question here, which I can see one more. Just give me a second for check the questions. Maybe I'm able to place what you can do. Yes, only AutoCAD or also BricsCAD. Not only AutoCAD, but also not BricsCAD. We are working just with the Autodesk, so AutoCAD or Revit side. So if you are working with already AutoCAD or also with Revit, you can use Caneco for make the design and place the components, make calculation, and so on. Canalys, sure, Canalys is possible to do by hand on implantation, or as a family directly on Revit side. So there are Canalys Revit families, so you can also place them directly and make the same thing also on Revit with Canalys. How to model the type B switch downstream of the protection? I just have to change the type of the circuit on connectivity. So it's just a change, because before I done it with I maybe switch back here, and here you can define the type of the switch. You can define a C breaker, B breaker, D breaker, GG fuse, and so on. So it's on you to define the type of the switch you want to have, and Caneco choose every time the easiest one from the catalog. On Caneco support is a circuit breaker switch. Can we, yes. No interface to ALPI, because if you want a multi-line diagram for the moment, because ALPI don't want it still now, so it's clearly the situation of ALPI by itself. But we have C electrical. So if you need a multi-line diagram or a cabinet designer 3D and so on, you can just transfer from Connectivity directly to C electrical. C electrical is a tool which is a competitor of ALPI, which is quite easier to use and as ALPI it is. So on that basis, if you want to see it once, just give me a notice. And also here we can arrange a one-to-one meeting and show you which way you can work with Connectivity and C electrical, which is also quite powerful on that place. Some more questions on that base? You can also unmute and ask the question directly if you want. Just note on the place, this session, the webinar is recorded. So all of you will get a video about this, or recorded video about this webinar. But if you need to see some more, have some questions, please don't hesitate to contact me directly, and we will arrange some one-to-one session, go through the project directly. I think it's more powerful as everything else. You can just you can define on Caneco, if you take a B breaker, again, just go to this regression. You can define the type of the protection, an SED, place an SED and ready, like a separate one. Or first you will place a sub distribution board and a sub bus bar, and place an SED to the bus bar and go on with the general B breaker. So also here on you. For the load balancing, yeah, it's also a way. It's quite more difficult to place a balance, completely balancing simulation on this point. It's this is something take much more time. So if for Axel in that way, here I can go further in one-to-one session with the support to support you here to make a full balance of the charger. You're absolutely right. If they use just 8 hours, not everything, and free power and so on. So we have to check it clearly. For sure, calculation of PT is based on the full use mainly in the moment, but you can also define every time if you have such more components a use factor. But it's something we have to discuss in detail with our support team, so they can show it in detail. I mean, the special one for 300 milliampere, not fuse. Also, you can make it for 300 milliampere and make just a general fuse. So here we can define also clear. So if maybe it's not so much clear for me what you mean, but you can define the undercurrent with all the fuses you want to place here. But Christoph, here, if you have additional questions, we can go further, more in detail, in a one-to-one session. It will make more sense as a general session here. So I will contact you after the webinar to make a one-to-one session to go deeper on the function here. So I think the 45 minutes left. I hope it was interesting for you and useful for you. You will get an information about a video directly after the session. I think it will be not directly just after the session. It will be tomorrow or next days. Our marketing team will send you the email with the video inside. But on those places again, please contact me directly if you need anything. And here I'll say directly goodbye. Thanks a lot for your time. And yeah, let's get in touch to go further. Thanks a lot, and I wish you a nice day. Bye-bye.